Hi guys, moving on with the next lesson here. Today we're going to be looking at solving exponential equations. And basically an exponential equation is one where the exponent is the unknown. So you can see here 2 to the power of x. We don't know what x is, and x is our exponent. So when the unknown is in the exponent, we call that an exponential equation. And today we're going to look at how to solve exponential equations. So looking at this example here, if we just think about it logically, let's say without using a calculator or any rules, I need to think of this as 2 to the power of what will give me 8. Okay, so I know 2 to the power of 1 is 2, so that doesn't work. 2 to the power of 2 is 4, that doesn't work. 2 to the power of 3, however, is 8. So I know that if I know 2 to the power of 3 gives me 8, I know in this case then x equals 3. Okay, so you can see here 2 to the x is going to equal 2 to the 3. And what we've done in this case here is we've changed the 8 and we've broken that down into 2 to the power of 3. Okay, and that's what we always want to do in these types of questions is when you have two different bases, like we have a base of 2 here and we have a base of 8 here, we want to express both using the same base. And that we're going to do by taking whichever the larger base is and expressing that in terms of the smaller base. So here, base of 2, base of 8. We're not going to try to express the base of 2 and change that to a base of 8. What we're going to try to do is take the base of 8 and express that as a base of 2. Okay, so how can I express 8 as a base of 2? Like we just said, 2 to the 3 gives me 8. Once I have the same base, so here I have 2 to the x, base of 2. Here I have 2 to the 3, base of 2. The bases are equal. If the bases are equal, that automatically means then the exponents have to be equal. So for this left side to equal this right side, the 2 and the 2 are equal, perfect. We know the x and the 3 have to be equal. So we make x equal 3, and that basically solves our equation. And that's what this box here is saying. If you get the same base, once you have the same bases, that means the exponents also have to equal for the left side to equal the right side. So that's how we're going to solve all of these questions. We are going to express both sides of the equal sign using the same base. That's the first step. Once you have the same base, then you simply equate the exponent. So make the left side exponent equal to the right side exponent and then solve for x or whatever the variable is, whatever the unknown is. Okay, so if that doesn't make 100% sense right now, don't worry. Let's do a couple of examples and hopefully that will make things more clear for you. Okay, so as I was saying, we want to express both sides of the equation using the same base. So I have 5 to the x plus 1 equals 125. And we're always going to try to express both sides using the lower base. So the lower number or the lower base here is 5. So I'll leave my left side as is. My right side, 125, I want to express that with an exponent with a base of 5. So if I do 5 to the 1, that gives me 5. If I do 5 squared, that gives me 25. If I do 5 cubed, that gives me 125. So I can rewrite 125 as 5 to the power of 3. Once I have my bases equal, now I have a base of 5 on the left side, base of 5 on the right side, I can simply equate the exponent on the left side to the exponent on the right side. So I do x plus 1 equals 3, and then subtract 1 from both sides. That tells me x equals 2. Okay. You can always check your answers. Okay, so you can always check your answers by taking whatever your answer was. So in this case, x equals 2. And plugging into the original equation and see if that will equal. So if I plugged in 2 here, I'd have 5 to the power of 2 plus 1. So 2 plus 1 is 3. And then 5 cubed is 125. So that tells me I've done it right. So with all of these questions, you can always do that quick check if you want to double check that you do indeed have the right answer. Okay. If it comes up that when you plug your answer in for the variable and left side doesn't equal right side, well, that will tell you then that you've made a mistake and to go back and redo the question. Okay, or at least try to identify your mistake and fix it. Okay, so let's do part B here, or let's go over part B. So again, base of 3 on the left side, and we have 9 on the right side. 9 is a larger base, so I'm going to try to express that 9 as a base of 3, so I can have the same base on both sides. So again, we can do trial and error. Some of you guys will know right away that 3 squared is equal to 9, but you could try 3 to the 1. Well, 3 to the 1 is 3. That doesn't help us. 3 to the power of 2 is 9. So I can rewrite this 9 as 3 squared. Now again, I have a base of 3 on the left, base of 3 on the right. Once my bases are equal, I can simply just take the exponent on the left side, which is 2x plus 4, and make it equal to the exponent on the right side, which is 2. And then solving for x, I get x equals negative 1. Okay, so I guess you could have tricks, if you want to call them that. For example, question C, you have 7 to the x minus 1 equals 1. So now this is pretty tough if you think about trying to express with the same base, because how can you rewrite 7 with a base of 1, or how could you rewrite 1 with a base of 7? So this is, like I said, a bit of a trick. We have to remember that anything to the power of 0 is equal to 1. So if we want to rewrite these with the same base, I can rewrite 1 as 7 to the power of 0. And the reason I use 7 to the power of 0 is because my base on the left is 7. So this way I have the same base on the left, same base on the right. Once I do that, again, I can equate this exponent x minus 1 to 0, and then solve for x, which is 1. So like I said, a little bit of a trick here. So if you do have anything ever equaling to 1, remember any number or any expression to the power of 0 is always equal to 1. So in this case, because we had 7 on the left side as the base, I used 7 to the power of 0 on the right side. Okay. The other thing that could be thrown at you is something like this. We have a base of 5, and then we have a base of 1 over 5, a fraction. So remember our rules. If we want to change a fraction into an integer, we can just flip this 1 over 5 and change the exponent to negative. So what do I mean by that? Remember, this is the same thing as saying 1 over 5 to the power of 1. We have a base of 5 over here. If I want to express this as the base of 5, well, I have 1 over 5. I don't want 1 over 5. I want it to be just 5. So if I flip 1 over 5, it becomes 5 over 1, which is the same thing as 5. And because I flipped it, technically there's that 5 to the power of 1 here. That power of 1 becomes, instead of positive 1, negative 1. Okay, so if you remember that rule, when you have a base to a negative power, it's equal to 1 over the base. Or basically what we're doing is flipping the base. So in this case, we flip 1 over 5 to 5. The power of positive 1, that is the imaginary 1 over here, is then rewritten as negative 1. Now we have the same bases, so we can equate x plus 3 to negative 1 and then solve. Okay, so that's pretty much how all of these questions are done. In example H and I, one extra step here because we have this extra plus 1 here. So what we would do in this case is move that positive 1 over to the right side and it becomes negative 1. Then do 17 minus 1 is 16. And once we have this, then hopefully you can recognize that I can write 16 with a base of 4 because I know 4 squared is 16. Right? If I just had 17 here, there's no way I could express that with a base of 4. So just remember to simplify first. So if you have something like a plus 1 here, move it over and subtract 1 and then answer the way we've been answering. Or in part I here, we have minus 3. So move that minus 3 over. It becomes plus 3. 122 plus 3 gives me 125. Now, once I'm at this line here, I can work with it and I can change 125 to a base of 5 because I know that 5 cubed is 125. So then I can write 125 as 5 cubed. Again, same bases at this stage. So once I have the same bases, I can equate 2x minus 5 to 3 and then solve for x. Okay. Looking at these other questions here, they do get a little bit more complicated where we have, basically we have a binomial in the exponent, a binomial in the exponent, binomial here. Here we have distributive property happening in the exponent. We have a coefficient on the bracket. So we still have to use our exponent rules here. But the first thing to do always is look at the base or the bases on each side and make sure they're expressed with equivalent bases. So for example, I have a 4 here, I have an 8 here. I usually look at the bigger base and try to express it as the smaller base. 8, I cannot express with a base of 4 because 4 to the 1 is 4, 4 to the 2 is 16. So I'm kind of out of luck there. So in this question, I need to change both bases. So we'd have to recognize that, wait a second, 4 I could express with a base of 2, because 4 is the same thing as 2 squared. And 8 I could express with a base of 2, which is 2 cubed. Okay, so sometimes you only have to change one of the bases. In a question like part J, or in all of these, J, K, and L, we have to change both of the bases so that they can be equal. So once I express both bases here as 2, so 2 squared was in place of the 4, 2 cubed I changed or replaced the 8 with. Now I have to use my exponent rules. So, well, technically you don't have to use your exponent rules, but what I mean by that is we have a power to a power. So I have to do 2 times x plus 1, which we see right here. I have to do 3 times x plus 2. So remember when we had power to a power, that was one of our rules in one of the previous lessons. We multiply the powers together. So once we do that, on the left side and the right side, I can equate both exponents. So 2 times x plus 1 simplifies to that. 3 times x plus 2 simplifies to this. And I just work my way through, isolate for x, and x gives me negative 4. Okay, so K and L are done the same way. You can try them on the blank copy of the lesson, but here we have to express both of these. We have to change both of them. So 27 and 9, again, you'd have to be able to recognize that 9 can be expressed with a base of 3, and 27 can be expressed with a base of 3. Okay. Once you do that, then you can go ahead and solve it just like we did part J. And then same thing for L, you'd have to recognize that both 25 and 125 can be expressed with a base of 5. Okay. So once you do that here again, remember your exponent rule is power to a power, so multiply 2 times 2y plus 5, which is that there. Multiply 3 times 3y, so you can do 3 times 3, which is 9, and then the y stays there. And then equate them. Once you equate them, solve for the unknown. Okay. You could be given questions like this, right, where just the numbers are given to you, or you could potentially have a word problem. So our word problem here says you start playing a game, your score doubles every day that you play. So your score is represented by S, and then for each day that you play is represented by D. So if you played for 3 days, D would be 3. If you played for 4 days, D would be 4. Okay. And the 2 here is representing the doubled bit. Okay. Your friend then joins or starts to play the game 3 days later, and her score quadruples every day. So S is still the score, D is still whatever day number she's on, and now instead of 2 for doubling, we have 4 for quadrupling. And then the minus 3 because she's 3 days behind. If you both score the same the first day you play, how many days will it take until she starts beating your score? So what you want to figure out is on what day will her score be equal to your score, and then pretty much any day after that, her score will be higher than yours. So to figure out what day her score will be equal to yours, well, your score is 2 to the power of D, which we have there. Her score is 4 to the power of D minus 3, which we have here. We just equate the two, and now we do the same thing we've been doing, express with the same base. So 4 can be rewritten as 2 squared. Once we have it rewritten as 2 squared, we use our power to a power rule. So 2 times D minus 3. And then we equate both exponents. So the exponent on the left is D. The exponent on the right is 2 times D minus 3. So we make those equal. Go ahead and simplify. And then isolate for D. And you can see as we work through here, we get an answer of D equals 6. So what that tells us is, on the 6th day, our friend's score will be the same as ours. So to answer the question, how many days will it take until she starts beating your score? It'll take 6 days for her to equal your score. And then at any point after the 6th day, her score will be higher than yours. Okay. It says here, use a table to check your answer. Again, you can go ahead and do that if you want. It's done here for you. So your score doubles every day. Her score, starting on the 3rd day, remember you start at the same score, quadruples every day, and you can see that on the 6th day, your scores will be the same. Okay, so that's today's lesson. Please do the practice sheet. and go over the examples if you need to any further, and ask questions as always. Okay, see ya.